This section's on 4.3 Polynomial Division. So we're using the Remainder Theorem, the Synthetic Division, and also the long division as well. So there's a couple of things we're going to do with the division part of it. So this is kind of a new concept if you've never seen this. Let me go back and refer to long division when we learned it, I believe in 4th grade is when you learn long division. So the concept of long division is similar to the 4th grade that you learn, but what we're going to do is we're going to put some variables in it. So it's going to cause a little bit of a different twist to long division. So let's go ahead and reflect back to 3rd grade or 4th grade. When we did long division in 4th grade, I believe it's like something like 301 divided by, let's say, something easy like 2 or something, right? And we had to put it into long division. The 2 right here is what we call the divisor, and this is right here is the dividend. So we would put the 2 on the outside and we put the 301 in the inside, and we would do the long division. So we would say 2 goes into 3 how many times? 1 time, right? So then you put in 2, and then the operation that you would do is a minus out here. So you would do 3 minus 2 gives you 1. Then you would bring down the 0 right here, and you do the same thing. So you go 2 times something has to give you the 10. So 5, right, gives us the 10. And then from here, this is 0. So this brings down all the way down to 1. And 2 cannot go into 1. So then this became what we call the remainder, right? This right here is the remainder. So let me write that remainder. This right here is called the quotient. And this is called the divisor. And so when you had something like that, we would say it was 15 with the remainder of 1. And back in the days in 4th grade, we put R, right, for 1. But when we get into the higher level math, we don't put R 1. But I think in this one, actually in my math lab, they do actually put something like this because it's the introduction or something like that. But later on, we actually put it into a fraction. So we'll see that, okay? So this is the concept that we're doing. We're doing the same concept. We're going to go ahead and whatever's on the bottom, we're going to put it on the outside, that divisor. This part here, the dividend part of it, goes inside the dividend. And then whatever's remained, or the answer up here is called the quotient. And then from here, the remainder down here, okay? So then they're asking us then to take this f of x equation, x to the third plus 2x squared minus 5x minus 6, and see if x plus 1 is a factor, and also if x minus 3 is a factor. So let's start with the first one, the x plus 3. So x plus 3, is that a factor? So when you're given something like this where you have x plus 1, you're going to go ahead and set that equal to 0. So x plus 1 equal to 0. And x is equal to negative 1. Okay? So then negative 1, oh, I'm sorry. No, we're actually wrong method. Okay, so we're actually going to do the x plus 1 out here. And then we're going to go ahead and put in the x to the third. Now, when you do this, actually, when you put inside the long division part of it, make sure all of the powers are represented, because if it's not, then you're going to have to put in something as a placeholder, and in this case it would be a 0. So since x to the third is the largest number as far as the power goes, make sure you have x to the third, x squared, x to the first, and then the constant. If you don't have something, let's say you didn't have x squared, you would put 0x squared to be a placeholder when you go into this spot right here. Okay, so let's continue on. So plus, and then it'll be 2x squared minus 5x minus 6. So now, when you do this, you're going to only work on is out here, this x right here. You're going to, for now, is ignore this until you get to this part right here. Okay, so similar to that 3rd grade math, we said 2 goes into what? For the 3, to make a 3, a closest number to the 3. But in this case, we actually want to make exactly, because your whole point is to cancel out this part right here. So if it doesn't cancel out, then you have to keep going until you find something. So you got to work on that one. So it's x times something has to give us x to the third. So it's x squared, right? Because it's x squared times this will give us x to the third. So this gives us x to the third. So now this is where it comes into play, because when you find this part right here, you're going to distribute to here and also into here as well. So this is x squared times 1 is x squared. Now, because it's x squared, you have to put it underneath the right spot, because if it's not underneath the right spot, then it's going to mess you up. So this is x squared right here, so I need to put it under here. So it's positive x squared, right? Because it's positive 1 times this gives us x squared. So what it looks like on the side then is what you just did was x squared times x plus 1. Basically, that's what you did, this distribution part of it, and you put it in here. Okay, so that's what it is. So then the fourth grade math still applies, where I'm still doing a minus right here. You want to cancel this out. That's the whole point. If you don't cancel this out, you're in trouble. So you got to make sure you find the correct quotient up here. Okay. Now this right here, this is where it gets a little tricky. So I always start from the top and I always go 2 minus a positive 1. So this is like basically 2 minus 1. 2 minus 1 is 1, positive 1. So it's a positive 1 x squared. Okay. So that's the remainder part. It's kind of like what we just did up here, because we did, we got the 2, and then 3 minus 2 gives us that positive 1. Same idea right there. Okay. Now, similar to this, whatever is up here, we have to drop them down. So similar to that, we're going to drop all of this down as well. So the minus 5x minus 6 all drops down as well. So we keep going. So then we do the same thing. X times something has to give us x squared. So also the trick is, if this is positive up here, most likely you're going to find something that's positive up here as well. Because if this is negative, you're also going to go ahead and put a minus up here. So that's another trick right there. So x times something has to give us x squared. So x, right? Because if it's x times x gives us x squared. So underneath it is going to be x squared. Now again, we do that little distribution. So this right here now is this x right here. That's this part right here. We're distributing it to x plus 1 right here. So x times x gives us x squared. X times 1 gives us x, positive x. So we're going to put it underneath here because this is the x right there. So then I do that. Fourth grade math again. I subtract it. This cancels out. Then we have is negative 5 minus 1 gives us negative 6. And then again, minus 6. Oops, don't forget the x. Minus 6 comes down as well. Okay, then you go again and say x times something has to give us negative 6x. So again, here's the trick right there. Since this is a minus right here, when I go up here, make sure you get a minus. So it'll probably be a minus 6, right? Because negative 6 times x will give us negative 6x. So again, this is up here is going to be negative 6, and we're doing x plus 1 distribution. So then that should give us negative 6x, negative 6 times 1, right? Which is the same thing as negative 6 times 1 right there is negative 6. So we have is negative 6. So then subtract. So this is gone. Now the reason why this is gone is because this is negative minus a negative. So this is negative and negative is plus right there. So it's not minus and a plus will cancel it out. That's why it works there. Okay. Then you also have is this one right here. So it's negative and minus is plus again. So this is going to become 0 right here. So in our case, the remainder is 0, so we don't have a remainder, okay? So is it x plus 1 a factor? So this is similar to what we did is this a root? What we do is we took the number, we substituted it into the equation, and if it came out to 0, then it's a root. Same idea. If this equation right here, when we do the long division, if it comes out to a 0 as a remainder, then we're saying, yes, this is a root. So when it is a root, you're going to write then f of x is equal to, so we're saying one of the factors is this right here, the x plus 1 works. So x plus 1, and then you're going to go ahead and write is the quotient that's up here, the answer part of it. So that's the x squared plus x minus 6, so plus x minus 6. So this is right here is what we called the divisor. This is the quotient. And then also you would do is plus the remainder. But in this case, in this case, the remainder was 0, so obviously we don't put plus 0, so we just leave the answer as this. Okay, so that's going to be the final answer right there. So in one of the problems on the MyMathLab, they're going to ask you to do the long division and write it up in this format as your final answer on the computer. Okay, now let's try the next one, that x minus 3. So is x minus 3 a factor of this original equation right here? So then again, you do the same thing. You would do is x minus 3 out here, and then you would do the long division of, let's see, x to the third, what is that, x to the third plus 2x squared minus 5x minus 6. So that's this part right here. Okay, so you do the same thing. You're going to go into it and say, okay, x times something has to give us x to the third. So it's x squared gives me x to the third. And again, if this right here, you forget to distribute, you might want to just put it on the side right here and say, okay, you found the quotient, which is x squared, but don't forget you're going to distribute as the minus 3 right here. So this right here is x cubed, right? And then this right here gives us minus 3x squared. So minus 3x squared. And oh yeah, okay. So then from there, the minus part right there, this cancels out. So then you have is 2 minus a negative 3. So negative negative is positive. So then it actually adds it up to 5x squared. Then we bring all of these guys down. So it's minus 5x and then minus 6. Okay. Then you do the same thing again. So x times something has to give us 5x squared. So again, if this is positive right there, it's most likely this is going to be positive. It's 5 probably because of this right here. And there's a 1 right here. So 5 times 1. But this is 5 times x only gives us 5x. And I need 5x squared. So you'll probably have another x right here, because that will give us then 5x squared. So again, the quotient is 5x. And then we're distributing it to x minus 3 right here. So then that should give us 5x squared. And 5x times negative 3 should give us negative 15x, right? And so then from here, subtract. This cancels out. Beautiful. And then what we have is negative 5 minus a negative 15. So technically this becomes a positive 15 right there. And this is a minus 15. So that's positive 10x minus 6. Okay. So the next part we do is x times again something has to give us 10x. So since this is positive right there, this is going to be plus, and probably what, 10? So 10 times x will give us 10x. So this is 10 up here, x minus 3 again. So if I distribute that, it becomes 10x. And 10 times negative 3 is negative 30. So minus, this cancels out. So it's negative 6 minus a minus, so it's positive. So the remainder is what, 24. So this is the remainder. Okay, so then when we write this up, as far as the final equation of f of x, so it becomes f of x is equal to, and now this is not, if we have a remainder like this is not a root. So make sure you know that is not going to work for us. But the final part that they're going to ask us on the MyMathLab is to write the final answer of this. So when you write this, it's going to be the divisor and the times the quotient. So this is x squared plus the 5x plus 10, and then the remainder, which is 24. So put plus R24, I believe is how they're going to write that up right there. Okay, so that's going to be the final answer part right there. So this is the long division method. So we're going to use a couple of methods in here. The second method is called the remainder theorem. So remainder theorem actually we did similar to 4.1 when I asked you, is this a root, right? So you took a number and you substituted in, and if the number came out to 0, it is a root. If it does not come out to 0, then it's not a root. So it's the same idea, that name is now the remainder theorem. So given an equation, if it's given to you already as x equals, then you just take this number right here, we substitute it into the original equation. So an f of negative 1 is equal to, and then negative 1 to the third power plus 2 times negative 1 to the second power minus 5, negative 1, minus 6. So when we work this out, let's see, this becomes negative 1, right? This is positive 1 times 2 is plus 2. This is positive 5 and minus 6. So that's what, 7 right here. And this is negative 7. So it comes out to 0. Perfect. So that means at x equals negative 1, it is a root. So what we did in last section, If it is a root, then we just drew a dot on the x-axis. And that's what you're continuing to do in this chapter, is try to find all the possibilities to find that root and then be able to graph it. So that's going to be remainder theorem. Now, the last theorem that we're going to learn is called the synthetic theorem. So, or the synthetic division. So synthetic division, it's kind of what I call it, a man-made equation, right? Because like synthetic materials, it's a man-made blend of material. It's not an actual like wool, right? Because polyester is actually man-made. So it's the same idea. So when we do this, it's kind of like a created equation as well. So it's similar to that long division idea, but in this fact, the synthetic, most people like it just because you just deal with coefficients. You do not have to worry about the x's and all that stuff. So let me go ahead and talk about then the synthetic. So we have is that still that divisor part on the outside, but we're only dealing with numbers, no x's and stuff until at the end. So when we have something like this, it says divided by x plus 1. You're going to set this equal to 0, and you're going to solve for x. So the root that we're looking at is negative 3 a roots, basically, for this equation when we graph it out. So that's what we're going to use. So that negative 3 is going to be out here as the divisor. And so then from here, we're going to go ahead and put in this part right here. Now, this is the part where you have to be careful as well, just like the long division. If I have x to the third as the highest power, I want to make sure I start off with x to the third, and then I just kind of write all the other ones, so that way if I don't see it, I can always put in the zeros. So this is x to the third, x squared, x, and then the constant. Constant is a number that we learned, right? So now we just write is the coefficient. So the coefficient of x to the third is 2, so we just put 2. Coefficient of x squared is 7, so we put a 7. Coefficient of x, we don't actually have an x, so a 0 is going to hold its place value for now. And then negative 5 is a constant because it's a number right there, okay? Leave a space right here because that's the work part of it. So the first part is you're going to take this, you're going to drop down the 2 right there. And then from here, this becomes a routine. So 2, after you drop that down, you're going to multiply it to the divisor out here. So that's the multiplication right there. So 2 times negative 3 is negative 6, so negative 6 comes in this spot right there, okay? Now, because it's synthetic, the operation from long division, which we learned in 4th grade, is minus, but the operation in synthetic is actually now plus. So you got to remember it's the opposite of the long division. So it's 7 plus a negative 6, which is 1, right? So once we get to this part, then it's routine, because then it goes 1 times negative 3 is negative 3. 0 plus a negative 3 is negative 3. Negative 3 times out here, negative 3 is what, 9? And then the 4 right there, right? Because negative 5 plus 9 is 4. Now, this last box right here is called the remainder when we do this part. Remainder. And this part is the quotient, which is normally the top part of the long division that we had. That's that part right there. So this part now is, once you're done with all of this, you have to write up the equation. So writing up the equation, whatever is the exponent up here, the highest power, you always do minus 1 to figure out what the exponent is down here. So this becomes now 2 to the second power, right? Because it's 3 minus 1 is 2, so it's 3 to the second power. And then you just kind of work your way down. So if this is x to the second, this would have to be x, and then this is your constant. So since 1 is positive, it just becomes a plus. So your final equation is 2x squared plus 1x minus 3. Now, if you did this same equation and you took this whole thing right here and you did long division, you would get the same answer as this part right here. Okay? So as I mentioned in chapter 3, there are methods that work fast, but then it doesn't always work. And then there is a method that always works. So same idea with this one. So let's just go back to that one. In chapter 3, we said the binomial factoring is fast, but it doesn't always work. But the completing the square and the quadratic formula, that's a guarantee. It will always work. Well, same idea with this one right here. The synthetic division is quick and easy because you can do this, but it doesn't always work. The reason why is it has to be a linear equation right here. It has to be x to the first plus some kind of number right here in order to put that number in here and make it work. If it isn't, then you're going to have to do the long division, which is by default always works. Okay, so in this final answer right here, when we write this up, then it's the same idea as the long division. We go f of x is equal to, and then so this part right here, the x plus 3 right there, is what we're going to put in the first part, x plus 3. And the quotient that we found was all of this right here. So 2x squared plus x, and then minus 3. And then plus the remainder. So in our case, remainder was 4. So our 4 was the remainder. So that's your final answer right there. This last example, on example 4, they're going to ask us to do a factoring of f of x and then solve the equation. And it's going to look something like this, where it says f of x is equal to x to the third minus 3x squared minus 6 plus 8. And they're going to ask us f of x is of something, question mark, is equal to 0 is what they're going to ask us. So you're trying to figure out is what is the root of this equation without them giving you any clues. Because on the previous examples, they asked us, is it factorable or does it go in? So then you actually did the long division or synthetic division to see if it works. And if it works, it was the remainder of 0. So if it does not work, then the remainder came out to some kind of number. Well, the same idea with this then. We just need to substitute in some numbers to see if it comes out to 0. If it comes out to 0, then it's one of the factors. And if it does not come out to 0, then it's not one of the factors. So we're going to have to do a guess and check, basically. Later in this chapter, they're going to show us a method, a better method to do this. But for right now, we're just going to go ahead and do a guess and check. So let's guess a number. Let's say x equals -1. So I'm going to test it at f of -1 to see if it works. So then from here, I'm just going to substitute into the original equation, -1 to the third power minus 3, -1 squared, minus 6, -1 plus 8. So let's see, this is -1 right there. +1 times -3 is -3. Negative and negative is positive, so positive 6 plus 8. So let's see, that's going to give us -4 right here. So -4 plus 6 is going to give us 2. So 2 plus 8 gives us 10. So final answer is 10. So 10 has a number, which is, that means that's a remainder right there. So that is not a root. So -1 does not work. It's not one of the numbers on the x-axis. So let's try another number. And let's just go the opposite direction at +1 instead. So I do the same thing, +1 to the third, minus 3, +1 squared, minus 6, +1 plus 8. So that's 1. This is going to be minus 3, minus 6, plus 8. So that's what, -2. And then that's going to give us -6 and that's -8 plus 8. Perfect. It comes out to 0. So 0 means that x equals 1 is one of the roots. Okay, so if x equals 1 is one of the roots, then I would have to do either long division or synthetic to figure out what is my quotient. So let's do synthetic because it's going to be something that's easier. So since 1 is already found for us, so we can go ahead and put 1 right here. And the equation up here is x to the third, so I'm going to go with x to the third as the highest, x squared, x, and then constant. So let's see, the coefficients are 1, 1, -3, -6, and 8. So again, then you leave a space right there to do some work. So let's focus in a little bit right there. Okay, so then we bring the 1 down. 1 times 1 is 1, -3, and remember the operation is plus out here. So -3 plus 1 is going to give us -2. -2 times 1 is -2 right there. This is -8. -8 times 1 is -8. 0, right? The last number is the remainder, which we expected because we said up here it works, so it should come out to 0. So this is also the way to check your work. So let's say you come out of 0 on the remainder theorem and it works, and then you try this method and you got a number. That means somewhere around here your arithmetic went wrong, so go back and check your work right there. Okay? So remember then from here to write up the quotient of this equation, since this is x to the third, then we start off with x squared. So that's 1x squared minus 2x minus 8. It should always work out that part. So that's going to be the quotient. And then the divisor in front of it is, we said, what, x minus 1. And the only reason it's minus 1 is because, remember, when you put it back into the parentheses, it's going to take this out of the parentheses, it's going to set it equal to 0, it's going to become positive 1. So when you put it back into the parentheses, it's always the opposite sign. So if this is positive 1, when you put it back inside the parentheses, it's negative 1. If this was negative 1, you put it back inside the parentheses, it becomes positive 1. So it makes that simple. So this is your final answer right here, is what you're looking for. Oh, no, we're solving. Okay, so because it says, and solve the equation. Yes, okay, so we're not done yet. So we continue on. So then this is the quadratic equation right there. So again, the quadratic, you can do a couple of methods. I'm just going to check the big X method to see if it works. So let's see, this is my A, C, and B. So negative 8 times 1 is negative 8, and negative 2. So negative 8 is 1 and 8, 2 and 4. And I need to get a negative 2, so I think probably 2 and 4, negative, positive. So that works for this one, and negative 4 times 2 gives me negative 8. Perfect, it works. Okay, so then the binomial factoring for that one is x, and then it's positive 2, so plus 2, and minus 4, so minus 4. And this part right here, we copy x minus 1 equals f of x. And then I think we have to solve for x right there, so let's continue on. So from here, x is equal to positive 1, x equals negative 2, and x equals positive 4. And those are going to be your roots right there, okay? And then I think we did the graphing portion of that from the last section. So once you know what the roots are, then we'll just put it on the x-axis and you start drawing it out, okay? So I believe those are lots of methods. So go back and rewind this video if you need to.